Hello YouTube, my name is Colton Laurie. I'm the owner and operator of a small shop in northern Minnesota called Rising Early Metalworks. We do everything from CNC machining, turning, milling, custom welding and fabrication. Basically, we're a job shop and I make as many different parts that I can. I've been in business for about 10 years. I started exclusively as a welder, doing mostly mobile welding. Over the last few years to help kind of spend more time with my kids and control my health a little bit more and take better care of my body, I've made a transition into CNC machining. My goal isn't to make videos that explain everything you'd ever need to know about how to be a machinist. I'm not the best machinist in the world. I make a lot of good parts, but I also make a lot of big mistakes. What I would like to do is share some of the mistakes I've made along the way, help answer questions that I had that I couldn't find answers to. One of the reasons I've been able to stay in business for so long is I have a pretty strong policy about taking on debt. I really don't like to have large payments, large loans kind of lingering over my head, whether it be for material or capital equipment or anything like that. It's not to say I've never done it, but I've been really good about managing and keeping my debt low in regards to the business so that if I have slow months, slow weeks, slow years, I don't have lingering payments that can kind of push me underwater. With that methodology and way I like to run my business, it means that I buy a lot of old used equipment or newer but heavily used equipment or equipment that is damaged or broken and needs something, and I get to spend a lot of my time instead of a lot of my money fixing equipment, dealing with problems, figuring out how to run these older machines that are a little bit left behind. So today I thought I'd start with my Hass Vf1 and do some videos about how I operate the machine. They're really comparable to a newer machine, and there's a lot of videos on that, but some of the quirks come into how you set up your computer to be able to transfer code into this machine, how I code slightly differently for one of these machines than I would for a new machine, but basically how I get this to work with modern toolpaths. It's not a difficult thing to do. This machine is actually incredibly capable. I run a lot of brand new machines at another shop, and this machine is able to hold the same tolerances. It's able to run a lot of the same tool paths. I'm able to make a lot of the same parts, but there are some quirks in the way that I program it and the way that I send code to it and things like that. And that took me a long time to figure out. I've had this machine for about a year, and it took me a long time to kind of figure out the answers to these questions for myself. So if you're somebody that's interested in picking up more budget friendly, older machine to be able to make your parts with or to be able to start your shop with, I hope that this can kind of help you work over some of the kinks you very likely may run into that I struggled with over the course of the last year. All right, first thing first here for this machine, I'm running on a American Rotary ADX 30. The ADX American Rotary is designed to work pretty well with CNC machines. My understanding, it has a little bit more ballast for keeping sustained power. I'm not an electrician by any stretch. I did put this in. I have it mounted here with a 3-phase panel to break out all my power to different machines. Unfortunately, I only have 4 breakers. I've got quite a few machines that run off of these. I'm not able to run them all at the same time. I did pick this unit up used, but they're relatively affordable when you look at the cost of getting 3-phase into your shop. One thing specifically with this Hass Vf1 that was an important note is this guy right here. I don't know if all the machines are like this, but this Vf1 is rated for 230 volts. Typically, you have plus or minus 10% is my understanding on that. The 3-phase between the power that I bring into the shop and the power that the phase converter outputs, I actually end up close to 250 volts, which is pretty awesome in terms of voltage supply, but it is too much for that machine. When I first hooked it up, I had trouble with it overheating. If I wasn't running it consistently, it would sit and it would get an over voltage warning. It would shut off. It was really frustrating. This actually took me a long time to discover just the right transformers to get. This is a buck boost transformer. If anybody ever has any questions about this, I could probably find my original purchase order. That said, I do remember it was about 850 bucks. And that was kind of a bummer. That was money that I really didn't want to spend. but it solved all of my problems. And it works great, and I have not had that problem since. So I'll flip my phase converter on here, and I'll be able to power up the machine. I often shut off, there's a breaker on the bottom of this phase converter. I often shut that off. Occasionally I have had times, I don't know if it's supposed to do this, but where I've had power come out of here with it off on one of the legs. And I like to be safe. I like to not send power to my machines when I don't need it. I also sometimes come in and work on my machines and I like to have the breaker off. So I always flip that off just as a safety precaution. I don't know that that's something you have to do, but I like to. Here's the label that says we're exactly at 230 volts. You can look at some of the maintenance stuff on here if you're able to read it. It's a pretty awesome machine, but you gotta send it the right power. If I didn't mention it before, this is a Hass Vf1. It's a 1996. It's almost as old as I am. In the world of CNC, that's a little bit of an old machine. I cleaned it up a little bit for this video, but I left some of the chips in there from this week because I'm being kind of lazy. If there's one recommendation I could make, my only regret with this machine is the size. When you look at the size of a machine, this is a 16 by 20 table with 20 inches of Z-travel. And when you think of a part that is 16 inches by 20 by 20, it's like, oh my God, that's huge. I can make some really big parts. When you start to put in some longer tools, some drills, you lose a lot of clearance here. When you put a couple of standard vices on, you lose a lot of clearance. And if you have to bring a big tool around the outside of your part, that cuts into your work area quite a bit. I am really happy with this machine. I don't think I'll get rid of it. I'm happy with the price I paid for it. I'm happy with the quality of it. I am in the market for a larger machine just to make it a little bit easier to get at bigger parts and to be able to have a little bit more high density work holding. There's a lot that I could do, put a base on here, dual station vices, things like that. But ultimately having a bigger machine is a pretty awesome thing to have. I do have this door very well engineered for a bypass. That's probably not a safe thing to do. There is a reason that they want you to have both doors closed to function this machine. But for video's sake, I'm going to leave it open for a little bit. And I'm going to step you through the power up cycle. On these machines, it is really, really easy. I'll try to keep as much of the controller in frame as I can. All right, power up is pretty easy. I hit my power on. Assuming I am sending the proper phases as well as the proper amount of power, this machine will power up. I apologize, everything is going to start getting a little bit loud. Now when I start up, I am going to come up here with a servo off alarm. It's going to say XYZ0. It also has up here loaded the last program that I was running. When I hit auto power up, right down here next to my reset button, that's going to start homing all of the axes. I happen to have tool 1 already in the spindle. If I didn't, it would come and grab that tool as well. The other important thing with this machine is having adequate air supply. You want to make sure that your air compressor is rated. I forget exactly what this takes. It's not a ton. I did have it on a pancake for a little while just because it was convenient, and I had one sitting here and I didn't want to plumb air lines. And that was really annoying because occasionally it would lose air pressure changing tools. And I didn't like that at all. It was very frustrating. And this controller from 1996, it's got a little bit of a different look, obviously, but the buttons are in the same place. The functions are very similar to the brand new machines that I run at another facility that I work at. So I'm going to show you some basic functions here. I'm not going to work through everything in this section because we're going to look at moving a program in here, but I will show you my program button will take me to the last program that I was running. My position will take me to my position screen with my operator 0, in this case my G54, but whatever offset my program was last working in. My machine 0, which obviously everything is homed, as well as my distance to go if I'm in the midst of running a program. This is one of the things that I really wanted to get into the video because this is something that I could not find up until about a month ago. I've had this machine for a little over a year and I was completely dropping the ball on this particular function. And that is my ability to zero my operator screen. This is really, really handy if you're using something like an edge finder, or perhaps you're using your Heimer indicator to measure the height on a part and then the height on a feature or something like that. That operator screen is really, really handy. I tried about everything, hitting X over here on my handle jog, origin, X alter origin, X alter origin here, and I was never able to get this screen to zero out and let me use an operator DRO. And if this is something that you've had problems with, I've read about it on forums. I was never able to find this information. I accidentally bumped a button and realized what I was doing wrong, and I felt like a total idiot because it's incredibly simple. And all I have to do is hit my page down button. When I hit my page down button, I can move through these screens independently, and then ultimately get back to my home screen. If I hit it once, you can see here, I am in my position operator working from memory. Here in this screen, I am able to say X, 0 point, and origin, and you can see that that will zero my X axis. I could do the same for Y, 0 point, origin, and I can do that for my Y axis as well. I believe that I can also punch in, I haven't actually tried this because I've only been using this feature for a couple days. I can say X 1.0, origin, and now I have 1 inch on my X. So if I wanted to move over exactly an inch, for instance, I'd be able to do that to find my zero. This is an awesome, awesome function that I was not able to use, and now I can. It's great. I can't believe that I hadn't looked at that before. If I'm in the market for buying one of these machines, and you're curious, how many hours does this machine have? How much time has it spent cutting? What has it done? If you can power it up at the place you're going to buy it, right here in this screen under your display, if you press current commands, that will bring you to this screen. I can page down and I can see all my stats on this machine. Now, this is one of the reasons that I'm so happy with this machine, and probably why it still holds good tolerances. My entire power on time is just over 1,000 hours. My cycle time is still under 400 hours, and my feed cutting time is about 227 hours on this machine. This is since the day it was made in 1996. You can't reset these. This is an incredibly low hour machine. In fact, I have machines that I run that are from 2024 and 2025 that have substantially more hours on them. Some 10 times the amount of hours because we run them 40 hours a week. So this is pretty cool. If you can see that screen, you can find out how many hours this has. You can find out it's had an M30 count of 4841. So this has made close to 5,000 parts potentially. Oftentimes an M30 doesn't necessarily mean that you ran an entire program. Might mean that you punched MDI or punched M30 into MDI and ran it 4,000 times. So it's not necessarily an accurate part count, but there's some interesting information that you can find in here as far as all of your feed times, your alarms, things like that under that current commands page. All right, now imagining that I already have a program loaded into this machine that I want to run, all my tools are set, my zeros set, everything like that. I can work over in this area from my list program here. I can find all of the programs that I have in this list here. Now, many of these here are either small parts that I was running recently or parts that I do often. This machine, one of the downsides is they have incredibly low memory. You can see here I've got, 10, 12 programs in here, and that is using up, what would that be? 84% of my available space. So I have 16% of my space left in this machine with 14 programs. That's pretty low. What I've found in filling this machine up, I can hold about 4,500 lines of code at a time. That's 4,500. I've ran programs through this machine with over 350,000 lines. So you're probably wondering how I do that. I'm going to step through next how I go about feeding this machine without overloading my memory. All right, I've got kind of a cool part here that I built on this machine. This is a collet holder. I got to make a few more of these, so I thought this would be sort of a perfect perfect example of a part that is going to be a little too much code for this machine to hold in memory. As you can see, I've got some kind of intricate tool paths. I've got radiuses on all the corners. I've got some nice features. Radius is inside all these. I am going to change actually here these facing passes. I did these with a large face mill. This part's a little long. It's not super well supported. I think I can get a much cleaner finish than that. My feeds and speeds probably weren't perfectly dialed. So I'm probably going to change that to a 1/2-inch end mill. It's going to take a little bit longer. It's going to be a few more lines of code. But I want to show you how I make a part like this in this machine. In this case, I've already got this part programmed. I did make a couple changes, nothing crazy. You can see this isn't overly complicated. This is not going to be a full Fusion 360 tutorial. I'm definitely not a CAD modeling expert, and there's tons and tons and tons of good videos out there. In this case, I would be doing the backside first, which takes about a 1/2 hour. In this case, 29 minutes. My top setup here, I've got a lot of intricate little tracing operations in here, and you can see that's scheduled to take about 55 minutes. That's gonna be pretty dense in code. So I'm gonna show you my process for transferring that file over. And then after I do it, so you can kind of see that this works, I'll go through some of the more intricate details on how we get the machine and the computer to talk to each other. Let's jump back into my adaptive path here that I have. One key thing, this particular adaptive path is going to come in here, I believe, and clean out these pockets. Most of the time with an adaptive path in Fusion, you should be using it for a roughing strategy. It's not a fantastic finishing strategy. If you're roughing, you don't have to be super worried about tolerance, things like that. This smoothing button right here knocks my code down by about 50%. This is under my passes tab. This has made it a lot easier on my machine to handle these codes. A newer machine or a super speed controller can absolutely handle many points in a line. This machine starts to struggle on some really fast passes, particularly aluminum and plastic. If I don't select that smoothing and I'm trying to run at full RPM, full feed rate of the machine, if I've got a point every 5/1000th of an inch, it's really going to struggle. That said, just clicking that button is usually enough. I'm gonna post-process this. I should be able to just do a Control V. Yep, I saved that. We'll do the same thing, paste this in here. A couple things just for my file management. When I am going to send a file to this machine, by and large, I leave it 1001 for my number. For whatever reason, I found, particularly when I get into higher numbers, I end up with some format errors, which is frustrating. I also make my file name and my comment the same. That way, the machine sees the comment as my file name, and the computer sees file name as my file name. And if these are different, it can get confusing when I jump back over into the machine. Other than that, there's some things that you can select. I do use a G0. I don't force the XY home on position indexing. I don't like that. Everything else that came out of this post was pretty much accurate. I'm gonna post this. I forget the name of this program that it dumps into. One of the problems that I have with every single one of these codes that threw me off for weeks in setting up this machine, for whatever reason, out of Fusion 360, let's see if I can zoom in here. My program number is set to 1001, and I end up with an O number of 001,001. That's probably something I can change in my post processor. I should. It makes me nervous going in there. So what I have to do is I have to come in and delete this 0. This machine, for its formatting, is looking for a %, an O number with 4 digits, and then your file name in parentheses, and it should also end with a %. If that's not the case in the code that you're outputting, that's something that you want to check. It's an easy thing to do. One of the other things that I do in my post processor here, as you can see, I have my tool names. They're not super easy to read, but I also throw in my Z minimum height, and that way I know, in this case, my parallels are about 110 thou below the top of my vise. I'm going to be contouring the outside of that with this 1/2-inch end mill. And 4 is my 1/2-inch end mill. 0.15. That looks a little more like it. I got about 30 thou above my jaw face. It's a little bit tighter than I like to be, but I don't want to cut this out of thicker material than it needs. So once I'm out of that, I'm going to hop into the program that I use to send files. I have that open here. Oh, I'm going to zoom out a little bit. This is called DNC for You. This is the program that I found that works well. That is DNC number 4, capital U, DNC for You. This has been the best program that I've tried. I've tried a number of different G-code senders. This one works great. When I first started with this, I used one of these Titan senders. This worked okay. I got this one used from a friend. It was not perfect. I keep it around just in case this computer ever crashes or I need to upload code from something else. But this program has worked really good. I won't say flawless. I do have a couple quirks with it that I've learned to work around. But this is the program that I use. So in this case, I'm gonna go File, and I'm gonna Open File, and that will take me, it should take me right to my NC programs. In this case, I'm looking for that YouTube test. When I do a lot of the same parts or a bunch of parts for a job, I like to save them into files. In this case, it's just getting kind of dumped in here. And that's gonna populate my G-code. One of the really important things with this DNC for You is you need a computer with a native COM port. I actually had a computer built for this, a decent desktop computer. I ordered it from a friend who builds computers. I'm not a computer guy. I'm not super tech savvy. This has been quite a learning experience for me. But you need something with a native COM port for this type of sending that I'm gonna do. I'll show you over here if I can find it. Up on my shelf. You can buy these on Amazon. I actually borrowed one from a friend and then bought my own, and you can see I've never taken it out of here. I've got some stickers in the bag from something else. I used one of these. This works to send code to the machine if you're going to save that code in the machine. You can send a file, you can store it in the machine, but again, that's only up to that 4,500 lines. This is a great way to do it when you're setting up. Say you don't want to buy a custom computer. You don't want to, it's hard to find something now with a native COM port. These do work, but you will not be able to send code and run it consistently. I don't know how that sticker actually got in there, because that is not a sticker from this product. But what I did next, I don't have the computer anymore, but I used to have a computer from the 2000s. And that was a laptop with a native COM port. I was able to kind of revive it, get it working. It really worried me because if that computer ever went down, I'm stuck until I can find another one. It'd be difficult to find somebody that can repair it, all that kind of stuff. So I opted to buy a computer, and actually the day after I ordered this computer, I knocked that laptop over and broke it, and it no longer works. Within this DNC for You, you can set up, you can run a free version of this to test it. Great. I think to buy the full version for a computer is about 125 bucks. Absolutely well worth the money. It's the cheapest, easiest option that I've found that is consistent and reliable. If I go to my CNC settings here, I'll show you first, select CNC. I'm working with this Hass Vf1. If I'm running more than one machine off of this computer, I'll change it. This is the main computer that I use for this. So I have the right thing selected. Within this, I can select my CNC settings. You can see in this COM port, there are some really important things in this COM port for connecting the machine and the computer together. There's a baud rate, there is your protocols, your data bits, parity, stop bits, your flow control. That is all very, very important. I don't know, I found these particular settings somewhere and they work and I don't change them. The one thing I have done is I will bump up my baud rate occasionally. You can see, I think my machine will only go up to 9,600. What I've found is 4,800 is completely adequate for what I'm doing. I haven't had trouble with it. When I bump up to a faster baud rate, you run the risk of more interruptions and things like that. The other thing that I want to do for this particular style of sending is I want to make sure right here I am on block send. It's difficult to see. Block send. That will work where it basically puts in a little bit of code into the machine runs it. When it starts to get through that code, the machine calls for more code, it uploads more. When it gets through that, it calls for the next block of code. That works great. I've always referred to that as drip feeding right here. Drip feeding sends a consistent flow rate to the machine. That is what I use when I'm sending a code to store in memory. But when I want to actually run through a program well connected to the computer, I'm going to use this block send. Hit my settings key and page down a little bit. There's a number of settings here to run through. Let's see here. Here it is, RS-232 ports. Use right or left arrow key, that bumps you between stuff. Let's see what I can get up to. I can run 7,200, 9,600. Oh, I can go way high in the baud rate. But 4,800 is what I found supplies enough data that I'm not lagging, that I'm not getting stuck as long as I smooth those tool paths. But it doesn't seem to error out. That's my particular case. I also have the parity, stop bits, synchronization, RS-232 data bits, my end of block pattern, all of that stuff matches from this machine to the computer. I don't know that the specific selections are incredibly important, but it is incredibly important that they match, and these ones happen to work. All right, now to actually get this code to start dumping into the control, there's a couple different options. If I was planning on sending this to the controller, let's say I had enough memory, I would go to list program. I would work my way down to all. I'm using my arrow key here. And down here, I would select receive RS-232. This here will say waiting. That is going to accept a program into the memory of the machine. Now in this case, this program I haven't scrolled down to see, but I think it's about 150,000 lines. That's about 10 times the memory that this machine has, and definitely more than the 16% that I have left. So if I were to send this into the memory, it would fail because my memory would be full, which is really annoying. So we're gonna come down here and instead we're gonna go to MDI. It aborted that, that caused an alarm. So here I'm in MDI. This has my code to warm up my spindle here for a second. If I hit MDI a second time, now it's gonna say waiting for DNC. When that says waiting for DNC, this controller is ready to start accepting code from that block send. Now let's hope this works and I don't have any hiccups. Now one of the tricks with this DNC for you that I had not found in the instructions or anything like that, my assumption would be that you hit send right here. You don't hit send, you hit window. Don't ask me why, I didn't make the program, I don't know what it means, but that's the button that you press. When I hit window, this is gonna pop up and you can see it is sending code through my COM port. It's only sending as much as the machine wants to take. It's gonna stop. When the machine works through that code, it'll pick up again. Now, if we come over here, assuming I didn't mess anything up, you can see right here, I've got program 1001, YouTube test, ready to run. Now, the nice thing about this, as opposed to using the drip feed function, this will fill up. I don't know what it's gonna get to. Right now, we're at about 5%. When this reaches the amount of memory that it can take, it's just gonna stop and it's gonna wait for more code. So I don't have to rush over here to hit my start button, right? I'm set up, I can wait, no big deal. I can let this code sit on the machine, I believe indefinitely. I don't know that for sure. Assuming all my tools and offsets are set up correctly, I can hit cycle start. When I hit cycle start, it's gonna start running through that code. See, I'm gonna come in here. I am gonna bump my coolant off as soon as this starts because we don't need that running. And you can see this is gonna start the facing cycle on that part. Now I don't have the part in here. I also didn't change this to the 1/2" end mill like I mentioned, but this is running that program that I input. This is set to run. This code's not gonna be moving by very fast. I might bring you back for one of the adaptive paths so that you can see how that runs when I start cranking this out. You can see here this stopped at 7%. It's just waiting for more code to come in. No big deal. When this code is done running, assuming it makes it all the way through the code, it will stop. It'll generally alarm out. It doesn't like an M30 on the DNC settings, so it'll say improper code. No big deal. I leave it as an M30 in case I take this to another shop and run it on a newer machine. Code still works. Not the end of the world. While this is running, I've got my options for my feed rate override, my spindle override, and my rapid override. In this case, I've run this program before. I'm not worried about slowing the rapids down. No big deal. If you wanted to, this is where you would do it. It also has options. One that I really like is optional stop. I use this quite a bit. It pops up there. My optional stop, I have an M1 in between each tool change. Usually once I see and hear a tool running, I trust it enough to leave. But if this was the first time I was running this program, or if I've got some close clearances on something, I'm running a new tool that I haven't tried before, I'm unsure about the way that I touched it off, that optional stop will stop it just before the tool change, and I have time to come over here and keep an eye on it. That's basically the whole thing. If I wanted to stop this at any point, I can still run my feed hold. That works great. It'll stop within the code. I can hit cycle start again and it'll pick up again. You can see that here. If I hit feed hold and go, it'll stop moving and then start moving again. So pretty simple stuff. If you're familiar with the Haas, the new Haas controllers, one of these old machines, it does not take a lot to get used to. I will take you around the back of the machine in a minute and I'll show you those RS-232 ports so you have a good understanding about how that connects and the important parts with that. All right, we're back here behind my computer to kind of show what we're doing. The important thing with your COM port is that you have a DB9 connector and that jumps to an RS-232 connector. What's important too, particularly for sending data over a long period of time, is that you have the shortest cable possible. You can run these through 100-foot cables. The shorter it is, the better. In my case, I have two connectors here. You can see up here serial port number 1, serial port number 2. Number 1 is for my connection to my computer. Number 2 is for my connection to my 4th axis. If you're running a 4th axis in your machine, I do have one for this. Hopefully I can do some setup tutorials on that as well, because that's been really difficult to find. The key part with this, and you've probably seen this in other videos if you're struggling with this, is you do need a null modem connector. I forget exactly what this does. It does something to flip the send and receive on these. I don't have a full understanding of it. Like I said, I'm not a computer guy, but a null modem connector and an RS-232 cable. In this case, on this machine, since I had it built, I got 4 COM connectors. I've got a couple other machines that I like to be able to connect to. I don't want to have to unplug from one COM port, change my CNC settings, things like that. I want to have all those settings in the machine, have 4 native COM ports that I can use, and that works out really good. This computer, by the way, you know, it seems like it would be an expensive task to get a custom computer built. This is only about 800 bucks, and it is so much more than what I need. I think I could have gotten a $200 computer with a COM port in it. It's really difficult to get them in a laptop, and a desktop seems to be just a better option, you know, kind of a dedicated machine for the shop. The reason this was so expensive, I got, I believe, a terabyte of storage and a terabyte of RAM. It's an awesome computer. I really don't think I needed that. I didn't realize how cheap desktops could be, and I told the guy I wanted as much RAM and as much storage as I could get. I wanted 4 COM ports, and I wanted it to be under $1,000, and he delivered, and I got a great computer. The other thing that I strongly recommend is running a battery backup surge protector on your computer. This does a couple of really valuable things. One, we're in a shop. I got other people in here welding sometimes. Sometimes I'm running other machines. Sometimes we'll be running grinders. I do trip breakers occasionally, and it sucks if you're in the middle of feeding that code and your computer shuts off. It's hard on your computer, it's hard on everything, and it'll make the machine stop, and I gotta figure it all out again. No fun. So the battery backup deals with that. The other thing is with the large amounts of power I'm pulling to fire up the spindle of the machines, it does occasionally draw the voltage down in the shop, and that can wreak havoc on computers, that voltage fluctuation. I think this is about 50 bucks. It's worth its weight in gold. It'll save you a lot of headache. I just picked this one up at Walmart and I've got consistent power to my machine without, if a breaker blows or anything like that. It'll also beep when I lose power. So I'll hear that beeping and I'll know that somehow I tripped a breaker and I can go flip that back on before this battery dies. But I think this will run the computer for about a half an hour. Super, super good investment. All right, guys, I think that about sums it up for this video. Really light overview on these machines. If you have any questions on it, I wouldn't say that I figured everything out, but I've got a pretty good idea how to run this thing, how to get code into it. I've had countless other problems that I've had to work through. I'd like to do some more videos on setting tools, setting offsets, things like that, right? You can't get a digital probe into this machine, I don't think, very easily. So I run a Heimer indicator and edge finders to set my work offsets. I'd like to work through that in this machine. It's really comparable to a new machine, but for anybody getting into one of these, it can be kind of a bear to figure out all the steps. And what I found is when it comes to crashing, tool offsets, work offsets are the #1 way to mess things up. Everybody thinks stuff happens on the programming side. It can. With modern CAM system, it's really easy to avoid crashes, but with a poor setup, it's almost inevitable that you're gonna rub vices, bang into stuff, drill deeper than you wanted, all kinds of things like that. So I'd like to do some more videos on it. If anybody has any questions, if anybody else has one of these machines, I'd love to hear about it. If you see anything that I'm doing wrong or things that I can be doing better, by all means. This stuff is really difficult to find information on, and I'm working from ground zero. This is the machine that I learned on, and I've done a lot of work on newer machines now and other machines and different types of controllers, but it took me a long time to come up with the information that I needed to get this to make my first part. Now that I'm about a year in, I can make really accurate parts, I can make really consistent parts, I can make parts efficiently. These machines are still worth using. It's depreciated fully in its resale value. I would say it's very far from depreciating in its utility. So if you see these on Facebook Marketplace, Craigslist, auctions, don't completely write them off. Some of them are used and abused and worn out and don't work very well anymore. But occasionally there's a diamond in the rough, and you can get yourself a good machine for about the cost of one payment on a new machine, and you can make the same parts.